review the principles to having a slant asymptote, also called an oblique. When the degree of the numerator is exactly one more than the degree of the denominator, you will have a slant asymptote. It's this line that your graph is going to hug as it goes out to infinity or negative infinity. How do we find it? We're going to use long division or synthetic. Synthetic will work if it's a quadratic divided by a linear term. And the answer to that division problem without the remainder, remember we get to throw the remainder out, it won't matter, is going to be our slant asymptote, okay, which we'll call SA. So in this problem, I have a quadratic polynomial being divided by a linear polynomial. The degree of my numerator is 2. The degree of my denominator is 1. Since 2 is greater than 1 by exactly 1 degree, then I'm going to have a slant asymptote. To find this, I can either use long division or synthetic division. I'm going to choose to do synthetic because it's a quadratic divided by a linear term. So setting up for synthetic. Remember my divisor, this x minus 1, I need to set this equal to 0. I get x equals a positive 1. That number is what goes outside our little L-shaped box here. Then here I write my leading coefficients of my quadratic. 1, 1, and then I don't have a constant, so I can fill in with a 0. This won't matter that much because remember, we throw our remainder out anyway. Process of synthetic division, bring down your leading coefficient. We're going to multiply this number with the number we wrote up here. So 1 times 1 is 1. And then we add. After we multiply, we add. 1 plus 1 is 2. Multiply 2 times 1. And add 0 plus 2. This is our remainder. We can throw that out. Our slant asymptote is going to be 1x plus 2. The line y equals 1x plus 2. And if we look at our graph here, this is the graph of the function we were just looking at, x squared plus x over x minus 1. If I type in x plus 2, you see this line, this slanted line, guiding our function as it goes off to infinity. So notice the green and the purple begin to merge as it goes off into infinity in both directions.